The question I have is, what is the electric potential at the point indicated with the dot in the figure? So the first step we have to do today is label the charges Q1, Q2, and Q3. See, Q1 is going to be the 2.0 nanocoulomb, the Q2 is 4.0 nanocoulomb, and Q3 is 2.0 NC, and then we connect the dots between Q1 and Q3 with the point in the figure. The next step, we write down the equations and the knowns. So our first equation is V1 equals K times Q1 over R1. Our knowns is Q1, Q2, Q3, where Q1 is 2.0 NC, Q2 is 4.0 NC, and Q3 is 2.0 NC. Our K is 9 times 10 to the 9th, and this is our constant, and given our knowns, we can plug in all of our knowns into the V1 equation we wrote down. R1 is the distance between Q1 and the dot in the figure, as we see over there. So R1 is 3 centimeters, which becomes 0.03 meters. After plugging all these into a calculator, we get V1 equals 600 volts, which is the potential at the point due to charge Q1. Our next step is to find V2, and we repeat the same steps like we did with V1. So our V2 equation is V2 equals K times Q2 over R2. Our knowns is Q2 is 4 NC, and our R2, using the Pythagorean theorem of 4 centimeters and 3 centimeters, we get the square root of 0.04 meters squared plus 0.03 meters squared. Now that we have all of our knowns, we can plug in our knowns into the V2 equation, where we plug in our constant multiplied by Q2, our 4.0 times 10 to the negative 9th coulombs, divided by our R2, which we use the Pythagorean theorem for, to solve for the distance between Q2 and the dot in the figure. This, after plugging into the calculator, gives us V2 equals 720 volts. Fourth step is to find V3 by doing the same thing we did with V1 and V2. So we write down V3 equals K equals Q3 over R3. And Q3 is 2.0 NC, and R3 is 0.04 NC. Or 4 meters, sorry. So V3 is K times 2.0 times 10 to the negative 9th coulomb divided by 0.04 meters, which is the distance between Q3 and the dot in the figure. Plugging this in the calculator, we get 450 volts. Our last step is to add all of V1, V2, and V3 to get V net. So we have V net equals V1 plus V2 plus V3, which is equal to 600 volts plus 720 volts plus 450 volts, which gives us 1,770 volts. So our V net is 1.8 times 10 to the third volt.